Hello viewers, welcome to my channel and thank you for watching the videos. In this video I will discuss question 5b of mathematics optional paper 1 UPSC 1992. This is complex analysis question. Here question is, let fz be analytic inside and on the circle C defined by mod z is equal to r, and let z is equal to r e to the power I theta be any point inside C. Prove that this. So let's do this. Here we have this circle which is denoted by C, or CR can be written in some notation. So this is C, and function fz is analytic inside and the boundary of this circle, and r is the radius, capital R. Z is a point which lies here. Z is equal to r e to the power I theta, which is given in the question. So this is Z is equal to, point is there, and now we can say that by Cauchy's integral formula fz is equal to f r e to the power I theta is equal to 1 upon 2 pi I closed integral. This is closed integral, and CR or C, we can say both are interchangeable we are taking, so we are denoting it by DC also, and zeta is equal to R, means there is a circle here which is zeta is equal to R, radius is this much, you can say that zeta is equal to R mod zeta. So f zeta upon zeta minus z d zeta. In some books other notation is there, fw upon w minus z dw. So this is the Cauchy's integral formula. Now the inverse of the point z with respect to C, or capital R means CR, lies outside C and is given by r square upon z bar. So when this is the condition, then Cauchy integral formula becomes this, that CR or C, f zeta upon zeta minus r square upon z bar d zeta is equal to 0. What is it basically? We said that r square upon z bar is outside the circle C, and therefore function there it won't exist, so it will be 0, fz will be 0 there, and that is why we got equation 2. And in other words we can say that function f zeta upon zeta minus r square upon z bar, this has no singularity within and on CR, because f zeta is analytic within and on CR. This is given in the question. And zeta minus r square upon z bar inverse is also analytic within and on CR, as r square upon z bar lies outside of C or CR, because it is the inverse point, and therefore zeta minus r square upon z bar is not equal to 0. So r square is equal to r into r, which is greater than r z bar mod, and because mod z is equal to small r, which is less than capital R, because I showed you that z lies inside the circle and capital R is the radius of the circle. Thus r square upon z bar is greater than capital R, therefore it is outside of that, and we got this, that function does not exist. So we got now the second equation. Equation 2 from one equation, we can have 1 upon 2 pi I integral, this all are closed integral, zeta is equal to r, this is on C, f zeta 1 upon zeta minus z minus 1 upon zeta minus r square upon z bar d zeta. After this, this is a question of simplifying it, and then what we do, we take the LCM. Here we took the LCM, so this becomes, here also we took the LCM, so z bar minus r square, and z bar will cancel out in denominators, zeta minus z, zeta z bar minus r square, this is the term. And we know that this f r e to the power I theta means in place of z we kept r e to the power I theta, and in place of zeta we kept capital R e to the power I